Good evening, ladies and gentlemen, and welcome to STEMwithKino.com. I'm Kino, and today we're going to talk about aircraft stability, maneuverability, and controllability. Okay, I didn't even know we paused. All right, there we go. There we go. So, we're here in Florida somewhere. It doesn't really matter. We're just talking about aircraft stability today, and we're not really talking about navigation or anything like that. So, let's go ahead and power up and get rolling. So, although no airplane is completely stable. No airplane's ever going to be completely stable. All airplanes have to have a desired a desired amount of stability. So let's get ourselves right here. There's this airborne, and there we go. Let's trim her out. So all airplanes are going to need to have a desired level of stability. Meaning that when we try to control them, the airplane's not going to be all over the place. As you can see now, you know, I've given the aircraft or brought the aircraft to a full power condition, and it's not all over the place. It's pretty much just kind of doing its thing, and you know, it's not all over the place. That would be a nightmare. So we want to make sure that we have some stability. So this quality of stability is very, very important. And throughout a wide range of flight conditions. Right now, we're in a climb. We could be in level flight. We could be in a turn. Um, we could be in a descending turn. We could be at high speeds, low speeds. Okay, but and the aircraft's inherent stability also affects its ability to recover from like stalls and spins and things of that nature, which are undesirable flight conditions. Um, Maneuverability and controllability are all interrelated design characteristics when aircraft are designed. So stability. Let's talk about the first part. Stability is the characteristic of an airplane that causes it to return to equilibrium or balance or steady flight after it's deserved. So, for example, if I'm flying a stable airplane that's disrupted, it has a tendency to return to its same attitude. Now, when we talk about attitude, we're actually in a nose up attitude. That's what we call it's an attitude indicator. We could be in a nose up attitude, nose level attitude, or a nose down attitude, which is basically climbing, level flight, or descending. All right. So after boom, we disrupt it. The airplane doesn't go nutty. Okay. All right. It kind of goes in a turn, and eventually, over time, she's just going to come back to a level flight condition after it's been disturbed. Now, that's a good thing. Okay, so for instance, if maybe your passenger kind of that was sitting up front with you bumped to control you, okay, the airplane doesn't go nuts, it doesn't go crazy, and it can be easily just kind of brought back to level flight condition. Okay, so that's desirable. Okay, so we want to talk about its its tendency to return to the position from which it was displaced. That's called positive static stability. I'll say it again, positive static stability. If we disrupt it, it has a tendency, it doesn't like keep going, keep going, keep going. Um, it doesn't keep going. All right. It kind of just wants to come back to its level flight condition. All right. So if we have positive static stability, its initial tendency is going to want to come back. So if I push forward, notice how the nose comes back. Okay, so that is positive static stability. That is the initial tendency of the aircraft to come back to its point of equilibrium. Right now, we're in a climate, we're in an equilibrium, we're in a balance for a climate. All right. Now, if I pull the nose up, what's the aircraft do? It has positive static stability if it initially tries to come back to the original condition it was in. All right, so we call that positive static stability. All right. However, since the aircraft doesn't immediately return to its original position, instead it does it over a period of time. All right. So it doesn't, like, if we pull up, it doesn't just immediately come back to bang like that. No, it happens over time, and we're almost stalled. All right. So again, positive static stability. I'm saying it again. I'm going to say it a couple times. It's the initial tendency to return to its desired flight condition. So you see it's going up and down. All right. I'm not really putting any input on the control yoke other than level flight. Okay, so it goes up and then it comes back down. So this is a stable aircraft. It just has characteristics that are going to bring it to its original flight attitude. Alright, you see, notice, just watch the horizon and the dash. It just comes back up. So eventually it's just coming back. Alright, so that's positive static stability. Alright. We're going to talk about dynamic stability. Alright. An airplane that exhibits positive dynamic stability experiences a series of progressively smaller oscillations. So that's what's going on now. It's going up and down, but notice that it's getting closer and closer to the horizon. And this is attributed to the amount of time that it takes for the oscillations to stop. So the oscillations are the up and down, up and down, up and down. We talk about positive static stability. It is its initial tendency to want to come back to its original flight condition. When we talk about positive dynamic stability, then we're talking about time. All right. Maneuverability. Maneuverability is a characteristic of an airplane that permits you to maneuver it easily and allow it to withstand stresses. Okay, so as we're turning and doing all kinds of wonderful maneuvers and things of that nature, it should be very easy. It shouldn't really be very hard. So basically, I should just be putting in gentle, not abrupt control inputs on the control yoke to make this happen. So if I want to come to level flight, I just gently tilt the yoke and the airplane just responds. So I'm going to go into a turn. I'll just gently, I don't have to turn like a fighter pilot. Another thing I'd like to mention is that when we go into turns, we actually, how should I say, we actually lose lift. Now let me explain what I'm talking about since I'm here, and then we'll talk about controllability. All right, so let's look here. Let's see if we can. So this is an aircraft in level flight. Notice the lift vector. This is just telling you, this is giving you an indication of the direction of the force and how strong it is. Okay. So this is a vertical lift component, and then we have the weight component. Now, we actually get heavier when we go into a bank turn. The vertical component of lift actually reduces because some of that force is going to be channeled into the turn. Now our total lift is in this direction, so as a result, what's going to happen is the aircraft is going to feel heavier, and you're going to have to apply back pressure on the yoke. And I wanted to demonstrate something now. If you actually bank 60 degrees, you will actually double your weight. So if your aircraft was, and the contents was 1,000 pounds, if you get into a 60-degree turn, you're actually going to double your weight momentarily until you come out of the turn. So maneuverability is a characteristic of an airplane that it permits you to maneuver it easily and it allows you to withstand the stress resulting from the maneuver. An airplane's size, weight, control system, flight control system, structural strength, and thrust determine its maneuverability. All right, so like an F-18 would have more maneuverability than a 737. Okay, like the 737 couldn't just be like, you can just turn it and just go nuts like this, unless you were at like it's a turbulence, penetration, or maneuvering speed. But every aircraft has a maneuvering speed. The next thing I'd like to talk about is controllability. All right, controllability is the capability of an airplane to respond to your control inputs. And as you can see, this thing's been doing it. So this aircraft is controllable. If I push forward on the yoke, the nose goes down. If I pull back on the yoke, it goes up. If I tilt the yoke to the left, it banks left. If I tilt the yoke to the right, it goes right. So basically, those are the three, or those are not just three, but those are the major topics. And let me get myself into level flight attitude here. Okay, so let me see here. Where are we at? We're over Florida. That's what I can tell you. We're over Florida. Okay, so that's basically it. Stability. This is the characteristic of an airplane in flight that causes it to return to a condition of equilibrium. Positive static stability is the initial tendency to go back to its original position. Positive dynamic stability is the lessening of oscillations. What we mean by oscillations is, if I pull up, all right, over time, see, this is one oscillation. Initial down, it passes the horizon, and without doing anything, it's going to come back up. Okay, so if we have positive dynamic stability, over time these oscillations are going to get less and less and less. All right. So you see how it's just really just coming back, all right, over time. I'm just tilting it just to level it out, not assist the oscillations. So over time, if it has positive dynamic stability, it is going to come back to its original flight attitude after we've displaced it. Maneuverability is the characteristic that permits us to maneuver it easily and allows it to withstand the stress resulting from the maneuvers. Okay, we can overstress our aircraft. Okay, if we push the nose down and exceed our max speed, VNE is what we call it, the never exceed speed. If we bank it too much and try to pull back pressure, we can pull G-load, we can G-load. And I'll talk about that in another video. Controllability is the capability of the airplane to respond to our control inputs, especially with regards to our attitude and our flight path. So stability, maneuverability, and controllability all refer to the movement of the aircraft about what are our three axes of rotation, which we talked about in another video. So we'll do a flyby, and I will see you guys on the next video.